So welcome back to the lecture series on basic civil and mechanical engineering. So first lecture we discussed about introduction to foundry shop. So we ended with the conclusion that foundry is a process where foundry is a place where metal is melted. So metal is melted in a furnace. So now we will discuss about one such furnace which is called as a cupola furnace. So it's a coal-based furnace. This is a scaled up version of your normal wood stove which we are using in our household. So just show you a diagrammatic representation. So this is a small scale cupola furnace used in foundries. Larger furnaces are available which will be the size of 60 to 80 feet tall. Such large cupola furnaces are also available. This is just a small scale representation of your cupola furnace. So here, as you can see, huge amount of heat is generated. I said that this cupola furnace is a scaled up version of your normal stove. Then how such huge temperatures are generated? So that's a question we need answering. So in a normal wood stove, the temperature may be around 200 degrees Celsius. At the maximum 300 may reach. But you need temperatures in the range of 1500 to 2000 degrees Celsius to melt steel. So to melt iron. The melting point of iron is around 1500 degrees Celsius. So a furnace has to generate minimum of 2000 degrees Celsius in order to melt metals with high melting points, such as iron. So how such high temperatures are generated? So let me explain. So if you take a fire triangle, we all know about a fire triangle. It's a three process integration of three things in order to create fire. You need fuel, first thing, then you need oxygen, and then you need a spark. Then those three things are there, then you can create fire. So fuel and oxygen plays a pivotal role. Fuel, in order to burn completely, you need sufficient amount of oxygen. If there is insufficient amount of oxygen, then complete combustion may not take place. If you take the example of coal, it's nothing but carbon. So carbon has to combine with oxygen in order to release carbon dioxide, which is an exothermic reaction. So a byproduct of that exothermic reaction is the heat which we are getting from the fire. So there is incomplete combustion. What happens is that carbon monoxide, instead of carbon dioxide, carbon monoxide will be formed, which generates the black smoke. As we see in our vehicles, when we raise the throttle, incomplete combustion takes place and carbon monoxide is emitted. Similarly, but if there is an abundance of oxygen, what happens is that complete combustion takes place and huge amount of heat is liberated. So if you take a furnace like this, as you can see, there is a spot called as air blast inlet here. There's an air blast inlet here, as you can see. This air blast inlet, what does is it gushes out huge amount of air into the furnace. So by doing so, what happens is that more amount of oxygen is readily available for burning. So by doing so, huge amount of heat can be generated. The normal, if you take a normal wooden stove also, if you supply extra amount of oxygen or extra amount of air, then temperature will be increased. So that's a basic principle behind the furnace. So abundance of air along with sufficient fuel will produce high temperatures. That's a basic functioning or the basic principle behind which a foundry works, a cupola furnace works. So there are various regions in a cupola furnace, as you can see, or various zones. So there's a spark arrestor, there's a charging door, air box, tires, tap holes, and slag holes, etc. I will explain the functioning of each of this in depth in the next lecture series. Sorry, in the next lecture video. To give you a quick recap, we discussed about a cupola furnace. So cupola furnace is a type of furnace which is used for melting metals. So it is a scaled up version of your normal stove. So high temperatures are generated here with the help of abundance of air. When there is abundance of air and abundance of fuel, then you can get complete combustion and huge amount of heat will be liberated. So that's how the furnace works. So thank you, students, for your patient listening. We will meet in the next lecture video.